Welcome my students. Now today's discussion is regarding force and motion. We know that the world is moving around the sun. This is the sun, the earth is moving around the sun. So the earth is always moving. So we inside the earth are also always moving. So we are actually the moving bodies. But our discussion is regarding the specific motion and rest. There is no absolute rest or motion because the earth is moving, therefore everything is moving. Now our state of rest or state of motion is actually not absolute. So there are two states regarding motion. One is state of rest and other is state of motion. When we are moving in a train, we see that the trees are also moving. So seeing the movement of tree, we can assume that the train is also moving. In this case, the tree is the frame of reference. And if the train is at a station, it is at rest in a station, we see that the tree is not moving. The tree is standing. So seeing the rest state of tree, we can take the decision that the train is at rest. So there are two states of a body regarding motion. One is state of rest and second is state of motion. And whether a body is under rest or it is moving, there is a requirement of frame of reference. Here in our example, the tree is the frame of reference. Now our discussion will be regarding motion. Actually, at a state of rest, there is nothing to do, and when a body starts moving, then there will be so many phenomena, and we will discuss about that. Now, for the first time, say a particle is moving and it go in this manner. So it has covered a distance from A to B and to C. So AB plus BC is the distance covered by the body. But there is a term displacement. What is displacement? We have to know. Displacement. Now, displacement is the distance covered by a body in a specific direction, and it is measured by the linear distance between the two positions, initial and final position of the body. Say a body starts from this point A, and after going in this manner, it returns at the point B, and it is the point, say, C. So the body has covered a distance AC plus CB. But the displacement of the body is the just straight line AB. AB is the displacement. AB, just AB. So what is displacement? Now displacement can be defined as a distance covered by a moving body in a specific direction, and it is measured by the linear distance between the initial and final position of the body. So in this case, AB is the displacement by the body. Its unit is meter in SI system or centimeter in CGS system. Its dimensional formula is L. Now speed, secondly, the definition of speed. The rate of distance covered by a body in unit with respect to time is called speed. The rate of distance covered by a body with respect to time is called speed. That is speed equal to distance divided by time. You can also say that the distance covered by a body in unit time is called speed. So you can define in terms of unit time or in terms of rate with respect to time. So its formula, dimensional formula, will be distance means length L divided by T, that is L T to the power minus 1. And its unit will be in CS, L centimeter divided by time second, or in SI, meter per second. This is about speed. If a body moves, then it must cover some distance and it will have some speed. So a moving body must cover some distance. Speed of a moving body can never be zero, and it must have some speed. Now the third is number 3, velocity. You know that velocity is the rate of displacement with respect to time. So velocity equal to displacement by time. Displacement by time. Now the dimensional formula of velocity will be displacement means L divided by time T, that is equal to L T to the power minus 1. The dimensional formula of speed is also L T to the power minus 1, as the speed is the rate of distance covered by a body. Distance is a scalar quantity, whereas displacement is a vector quantity. Displacement being a vector quantity, velocity is also a vector. Velocity is also a vector quantity. And keep in your mind that speed is a scalar quantity. Now the unit of velocity will be the unit of displacement, that is in SI, it will be meter divided by time, meter per second, or meter second to the power minus 1. And in CGS, it will be centimeter per second or centimeter second to the power minus 1. So this is about velocity, and again keep in your mind that velocity is a vector quantity and speed is a scalar quantity, though they are dimensional formula and their units are same. Now velocity, apparently it appears that speed and velocity are almost same, but there are some fundamental difference between speed and velocity. Number one, speed is a scalar. Speed is scalar, but velocity is vector. Number two, speed can never be zero. Speed can never be zero, but velocity may be zero. Number three, uniform speed does not signify uniform velocity. Uniform, keep in your mind the word uniform. Uniform speed does not signify uniform velocity, but uniform velocity signifies uniform speed. If a body moves with uniform speed, its velocity may not be uniform. May be uniform or may not be uniform. But if a body moves with uniform velocity, its speed must be uniform. Difference number 4 is the definition. What is speed and what is velocity? And these are the main differences between speed and velocity. Now, acceleration. It is the rate of increment of velocity with respect to time. If body moves with gradual increasing velocity, then the rate of increment of velocity with respect to time is called acceleration. You can also say that the increment of velocity in unit time is called acceleration. Same will be the definition. So acceleration equal to increment of velocity, that is velocity by time. The acceleration equal to velocity by time. For velocity, the velocity is displacement by time. So acceleration equal to velocity by time, that is equal to displacement by time, that is equal to displacement by time square. Displacement by time square. So the dimensional formula is L by t square, finally L t to the power minus 2. And its unit will be L means centimeter per second square and meter per second square or meter second to the power minus 2. You can write in any way. Centimeter per second square or centimeter second to the power minus 2 and meter per second square or meter second to the power minus 2. And now retardation. Retardation is the rate of decrement of velocity with respect to time. If the acceleration be positive, then retardation is negative acceleration. Why is retardation called negative acceleration? Actually, let us consider a body moving with uniform velocity u, and after decrement of velocity it becomes v, that is v less than u. So the decrement of velocity is v minus u in time t. So the change of velocity is v minus u and the time taken for this change is t. Now retardation RET, and that is retardation equal to u minus v, this is the change of velocity, by t, that is equal to minus common v minus u by t, and you know v minus u by t equal to a, acceleration. Acceleration equal to v minus u by t, v final velocity, u initial velocity, t time. So acceleration equal to change of velocity v minus u by t, this is acceleration. So retardation equal to minus acceleration, that is negative a, negative acceleration. So we can say that retardation is negative acceleration, and the dimensional formula of retardation is also same as acceleration, that is L t to the power minus 2, and the units will also be same, centimeter per second square or meter per second square. Now we have to do simple numerical regarding acceleration and retardation. Simple numerical. How do you solve? A body at the initial velocity 36 km per hour. And after 10 seconds, its velocity becomes 72 km per hour. And the acceleration of the body. Again saying a body had an initial velocity 36 km per hour, and after 10 seconds its velocity becomes 72 km per hour. Find the acceleration of the body. Now we'll solve the problem. Initially you have to change the velocity from kilometer per hour to meter per second. So initial velocity is taken as u. Let u be the initial velocity. U equal to 36 km per hour. That is equal to 36 into 5/9 meter per second. Kilometer per hour can be converted into meter per second by multiplying 5/9. Kilometer means 1000, hour means 3600. 1000 by 3600, that is 5/9. That is equal to 420 meter per second. And now final velocity will be v, and v equal to 72 km per hour. That is equal to 72 into 5/9 meter per second. That is equal to 840 meter per second. Now we have to find the acceleration. Acceleration a equal to v minus u by t. That is equal to 40 minus 20 by t. What is the time taken for this change of velocity? After how many seconds? 10 seconds. So 40 minus 20 by 10, that is 2 meter per second square. So 2 meter per second square is the acceleration of the body. So keep in mind that formula of acceleration is v minus u by t, and you must take the velocity from kilometer per hour in meter per second in SI, or you can take in also in CGS, centimeter per second. It will be convenient to take it in meter per second. So these are the definitions, and we have already gone through the definition of momentum in the last chapter. Last chapter we have shown that momentum is mass into velocity, and that will be mass into velocity. Momentum, again we are repeating momentum. In the last chapter we have done regarding momentum, mass into velocity. Its dimensional formula, mass m and velocity lt to the power minus 1. So the dimensional formula of momentum is m lt to the power minus 1, and its SI unit will be for mass kg meter per second velocity. So kg meter per second, and in CGS it will be gram centimeter per second. And these are the definitions regarding rest and motion. It is completed. Thank you, my students. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.